All right, in this video, we're going to be talking about section 7.2, which is going to be continuing our conversation on quadratic functions. And we're going to be talking about something called standard form. All right, so to review where we've been, I've got a warm up for us to do. The better you know this topic, the easier everything's going to be for you. So at this point, I would expect you to know that y equals x squared is known as the parent function of a quadratic graph. It is the most basic quadratic that you can graph. And you can quickly graph it. You know the vertex at 0, 0. And then we've talked at length about this pattern. If you go over 1 up 1, over 1 up 3 more, over 1 up 1, 2, 3, 4, 5 more. You just go up the odd numbers 1, 3, 5, 7, however far you want to go. And again, why is it that? Well, again, this is all about shortcuts. And we know this is the 0.11. We know this is the 0.24 because I plug in 2 and square it and I get 4. I plug in 3, I get 9, 4, I get 16, etc. And what did the difference in those numbers happen to be? It happens to be going up 1, up 3, up 5. So why is it 1, 3, 5? It's because what's what the numbers dictated as we create the table of values and graph them. All right, so from knowing the parent function, the idea is we looked at different examples of what happens as we now manipulate the equation y equals x squared. For example, what happens if we put like a minus 3 at the end? And what we learned through a table of values and graphing was that the graph is going to stay exactly the same picture as we just made. It's just going to shift down 3. So we're starting here and we're going to go up 1. We're going to go over 1 up 3. And we're going to match on the other side. And at very minimum, I want 5 points, the vertex, and then 2 points on each side. Speaking of the vertex, we should probably get in the habit of labeling this. This is the point 0, negative 3. This, of course, is the point 0, 0. All right, and then the next thing we had looked at was what happens if instead of having a number being added on the outside of the function, which is what I would describe what we did on the second question, that minus 3 is on the outside. This time we have a plus 4, but it's on the inside. And what we saw through example was that this graph is going to stay exactly the same. It's going to shift over, however, 1, 2, 3, 4. It's going to shift over to negative 4. It's always going to go to the opposite of that number simply because the vertex happens when you do 0 squared, right? 0 squared, my vertex is at 0, my vertex is at 0. So what's going to make us do 0 squared here? Negative 4 will. So our vertex is actually going to shift over. And again, the y is based on the math of it equaling 0 on the inside. But why does it do this? Because we made a table of values and we saw it happen. And so I don't need to do 100 examples to recognize a pattern. I did enough. And now I recognize and trust the fact the pattern will continue. So then, speaking of patterns, I know it's going to be up 1, and I know it's going to be up 3, and I am done and graphed very quickly. This is the vertex is at negative 4, 0. All right, and then what happens if we have both of these things? And what we saw is that both of these things are then going to happen. So this is going to be that same graph that we started with, that y equals x squared graph, except it's going to shift to negative 1 and down 2. So we're going to go over 1 and down 2, which should put us right here at negative 1, negative 2. Then we follow our pattern, over 1 up 1, over 1 up 3 at a minimum. Certainly doing more is great. 1, 2, 3, 4, 5. If you can fit it into your reasonable size graph, the more points the better. Just helps you draw a better picture. But at a minimum, 5 points. All right, and then the last piece was, all right, now we have a times 2 out here, and that is going to impact us as well, but it's not going to change what we know the vertex to do, which is we know it's going to go to positive 3 and up 1. So we're going to go to 1, 2, 3, and up 1. So my vertex is here at 3, 1. Now, my normal pattern of 1, 3, 5, what we saw through example, is when we have a number being multiplied out front, it's just going to multiply and change the pattern. So my 1, 3, 5 is going to be doubled because we have a times 2. So that ends up being a 2, 6, 10. So I'm going to go over 1, not up 1 this time, I'm going to go up 2. I'm going to go over 1 and up 6. 1, 2, 3, 4, 5, 6. All right. And there is my graph. We should kind of call in another piece of information we've sort of glossed over, and that is this idea of the axis of symmetry. The axis of symmetry is this mirrored line, and it's always going to be a vertical line that passes through the vertex. Okay, so our vertical line passing through the vertex is very easy to write because all vertical lines, as you may remember, is going to be written as x equals because all of the x's stay the same. And what are the x's? They're going to be 3 because that's the where we're located. That's x equals 3 is the vertex. So this axis of symmetry would be x equals -1. This one over here would be x equals -4, etc. This one, the axis of symmetry hasn't moved from what we would expect. That's the vertical line, x equals 0. All right, so without really much effort, just a little bit of understanding how these numbers affect us, we can graph very quickly. All right, let's continue. What we just reviewed is something called the vertex form of a quadratic function. And so we know all of the stuff that this does because we just saw it happen. We know that the A is what's known as the vertical scale change. It's what changes our scale from the typical and doubles it or triples it or halves it or flips it. And then my vertex, we know we go to the opposite of h. So that would be, or negative h would be to positive h. That's where the direction we moved. And then we go up k, we go up k. So that's exactly what we just did. This is known as the vertex form. We like vertex form because in theory, we look at the equation and we can clearly see exactly what's going on and we can graph it. But we're going to be given a different version of a quadratic function, and that's what's known as the standard form of a quadratic function. You will notice that a quadratic, as we learned in the previous chapter, is just a version of a polynomial, is a polynomial with a second power as the highest. And if you remember, standard form of a polynomial was when you write it from highest power to lowest power. So this is what's known as standard form. We've already kind of established that in the past. All right, without going into a lot of why, because the why is a little bit complicated for where we're at the moment, we're just going to talk about some facts. The x-coordinate of the vertex. So in this format, we cannot just look at the problem and see where the vertex is. It doesn't just jump off the page at us like it does in vertex form. So what we can do is we can find the x-coordinate of the vertex by doing, and again, this we're not going to tell you about why this works at this point. It's simply established we can find it by doing -b over 2a. So we go up to our quadratic and we identify our b value, which is always the one attached to x, and then the a value, which is the number in front, just like it was in the vertex form. So -b over 2a, that'll give us, right, if we're talking about graphing that bottom or top point on a parabola, that's going to give us our x-coordinate of the vertex. And then, so you calculate that out and you say maybe it's 2 or something. So then the y-coordinate of the vertex can be found by plugging that number back into the equation for x, right? So if we plug in our number for x and we do the math, we're going to find out what the y value is going to be. So if you want to know what the x value is, you do -b over 2a. If you want to know the y value, you just plug it in to see what it gives you at that point, which hopefully should make some sense. The axis of symmetry, no surprise based on what we just talked about, is the vertical line that passes right through that point. And so the x-coordinate of -b over 2a, that's going to be what the axis of symmetry is. Because again, -b over 2a establishes where we're at as an x, and we're going to graph our parabola. So obviously the vertical line going through that would be at that same number. And then this a value, it's doing the exact same thing that it did before. So notice these are different variables here because they're in different format with the h and the k, but the a is still the a, meaning that number is still the scale change. Okay, so if we know the vertex and we know the scale change, then I can graph a parabola with no effort whatsoever, just like before. The difference here is I can look at it and find the vertex, and then I know what to do with the scale change. Here we have to calculate the vertex, but then I still know what to do with the scale change. All right, let's see this in action. All right, example 1. First of all, these are in vertex form. Let's turn them into standard form. So in other words, we're going to now just do the math that this says. So x plus 4, the quantity squared, we should remember is x plus 4 times x plus 4, which is not just squaring the x and squaring the 4. Like we've established that in the past. That's something that we forget, and a lot of kids forget throughout the years. So the answer to this question is going to be y equals 2 times x plus 4 times x plus 4 plus 3. So we're going to FOIL the x plus 4's together, or use our shortcut. So I get the 2, and then I've got x squared plus 4x plus another 4x plus 16. And then we have our plus 3. Following order of operations, we distribute the 2. So 2x squared, 4 plus 4x, that's going to be 8x, but we're multiplying by 2, so that's going to be 16x. 2 times 16 is 32. We still have our plus 3, which I can combine with the 32. So in standard form, we would have this right here. Okay. Now, most of the time, we're not going to want to take it out of standard form because out of vertex form, because vertex form is the best form, but we need to be comfortable with the math should we be called upon to simplify. So we just have to make sure we square correctly. So over here on this one, we're going to do the same thing. We have 1/2 times, and then I got to do x minus 2 and x minus 2, and then plus 7. So I've got to do the x minus 2's first. So I have 1/2 times x squared minus 2x minus 2x plus 4, and I have my plus 7. Distribute, I get 1/2 x squared. Negative 2 and negative 2 make negative 4, but I'm doing half of negative 4, so that brings it back to negative 2x, and half of 4 is 2, and I have my plus 7. 1/2 x squared minus 2x plus 9. That would be in standard form. All right. Going the other way is more complicated, and that is not something we'll be discussing at this time, and I'm not sure we will cover it this year. All right. Finding the vertex, the axis of symmetry, and the y-intercept of the function. Graph the function. And then once you've graphed it, let's rewrite it in vertex form. So it sounds like a lot, but here's what we got to do. We know that the x coordinate is going to equal negative b over 2a. So all I have to do is identify those values. So x equals negative b, so that's negative 4, over 2a, so 2 times, and my a value is 2. So x equals negative 4 over 4, x equals 1. So what I have found is that my vertex is at 1 comma something. And if you want to know the y coordinate that goes with any x value, right? So just like a table of values, we've just narrowed down our table of values. I want to know what's happening at 1. I've established this is the vertex. Now let's plug in 1 and see what the y value is. So when I plug in 1, I get y equals 2 times 1 squared plus 4 times 1 plus 3. I follow the order of operations and square the 1 first. So 1 times 2 is 2 plus 4 plus 3. Y equals 4, 5, 6, 7, 8, 9. I've got the point 1, 9. All right, so I know now where my vertex is. It's at 1, 9. So over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Now, what does the rest of the graph look like? Well, that's when we have to think about our scale change. Our scale change is the A value. Our scale change is 2, which means our 1, 3, 5 pattern has been altered and turned into 2, 6, 10. So I'm going to go over 1, up 2, over 1, up 1, 2, 3, 4, 5, 6. And we'll call it good there. And there is my graph. Okay, so a little more work because you have to calculate the vertex. But once you know the vertex, then we just follow the pattern as we have done in the past. All right, let's see what it asked me to do. It asked me to find the vertex. Check. The axis of symmetry. Okay, that's just the vertical line. So axis of symmetry is going to simply be the line x equals 1, because that's that vertical mirror line right here at 1. And the y-intercept is simply where the graph crosses the y-axis, and that happens at 0, comma, looks like at 10. Nope, 11. Okay. Whoa, something's very wrong here. Oh, shoot. You know what I did wrong? Lots of things. Well, one major thing. You were probably screaming at the time, but guess what? I just dropped my negative right there. The vertex is at -1. So that means my graph is incorrect. So I could edit the video, but I am going to keep it because I want you to see that these things happen to the best of us. So let's fix our graph. So since my vertex was wrong, my x-coordinate, that means my y-coordinate was wrong as well. So I need to now plug in -1 and do this correctly. 2 times -1 squared plus 4 times -1 plus 3. -1 squared is +1, so I get 2 times 1 minus 4. That's where we're going to have our big change. I get -2 plus 3. Let's see. Something's still not working out. No, that's right. -2 plus 3 is 1. So I have a vertex at -1, +1 right there. All right. Now, our scale change was correct. It is 2. So we're going to go up 2 and then 6 and then 10. Over 1 up 2, over 1 up 1, 2, 3, 4, 5, 6 more. Mark it on both sides. There's our correct answer. A little sketchily drawn. All right, so now my axis of symmetry. So first of all, let's do our vertex. Our vertex is at -1, +1, which means my axis of symmetry is x equals -1, because that's the vertical line, that's the mirror. Our y-intercept is the point 0, 3, which we already knew. If we remember math from our past, you can always find the y-intercept by letting x equal 0. So if I plug in 0 to these two x values, I'm left with simply +3 on the end, which is why the y-intercept is 3. And exactly how I knew I made a mistake before, because I found the y-intercept was 11, and I knew it had to be 3 based on the fact that when I plug in 0, I get 3, not 11. So that's how I knew I had made a mistake previously. All right, the last thing I'm asking you to do is now let's rewrite this in vertex form. So we know all the pieces, y equals a x minus h squared plus k. This is vertex form. And we know what these numbers tell us. So we know that there's a scale factor of 2. So we know we have y equals 2. And we know our vertex moved to the left 1, and we know it always moves in the opposite direction. So since it went to the negative 1, we know this had to be x plus 1. And then it went up 1, and so we have our squared there. So we know that our vertex form would be this. All right. Let's move on and do a couple more problems. All right. So y equals x squared plus 2x plus 4. I need to find my vertex, which is going to be at negative b over 2a. So x equals negative 2 over 2 times 1. Our a value is 1. X equals negative 2 over 2. X equals negative 1. So my vertex is at negative 1 comma something. To find the something, I'm just going to plug negative 1 in. So I get y equals negative 1 squared plus 2 times negative 1 plus 4. Y equals 1 minus 2 plus 4. Y equals, what was it, 3? Yeah, y equals 3. All right, so now I'm going to go to my graph. Negative 1, 3. And now what's my scale change? Well, the scale change is 1. In other words, there is no scale change because that's the a value. In front of x squared, that's our a value right here, right? A is always the number in front of x squared. So that means we're doing 1, 3, 5. So over 1, 1, 1, 2, 3, 1, 1, 2, 3. That's the minimum expectation. We'll call it good. So I have my vertex at negative 1 comma 3. I have my axis of symmetry at x equals negative 1. That's this vertical line right here, that mirror. My y-intercept is always just going to be the number out here by itself. So that's going to be 0, 4. But we can also see that happen on the graph right there. And the last thing I want is vertex form. So we have y equals, my a value is 1, so I don't need to write it. X, we moved over to negative 1 again, so that would be x plus 1 squared, and we moved up 3. So that should be in vertex form. And how could we test to see if we did that right? Well, we could just do what we did in the previous example. We could turn this into standard form by multiplying x plus 1 times itself and adding 3 and see what we get. All right. We'll do probably one more and we'll see where we're at. So part C here, I need the vertex. So I'm going to do negative b over 2a. So x equals negative 3 over 2 times negative a half. X equals negative 3. 2 times negative a half is negative 1. X equals 3. So the vertex is going to be at 3 comma something. To find the something, we got to plug it in. So I'm going to find f of 3. Again, just taking my function written in function notation, and this means I'm plugging in 3. So it gives me negative 1 half times 3 squared plus 3 times 3 minus 7 equals negative a half times 9 plus 3 times 3 is 9 minus 7. Half of 9, that's going to be negative 9 halves, or 4.5 for you decimal friends. Negative 4.5, 9 and 7 make 2. So that's going to be negative 2.5. All right, so my vertex is at negative 2.5. All right, let's think about what this graph is going to look like. I'm spotting the vertical scale change. And I see that it is a negative 1/2, which means two things. It means I'm going to be going upside down, and my scale change of 1, 3, 5 is going to be a half, 3 halves, which is just 1.5, and 5 halves, which is just 2.5. So my vertex is at positive 3, down 1, 2 and a half. So now I'm going to go down, and I'm going to go down over 1 and down a half. I'm going to go over 1 and go down 1, 2, 3 halves. And then I'm going to go over 1 down 1, 2, 3, 4, 5 halves. Nice thing is we hit some whole numbers along the way. Makes it easy to stay accurate. Axis of symmetry. X equals 3. Vertex. 3 and negative 2.5. Y-intercept is going to be, should be at negative 7, because when I plug in 0, I get negative 7, and it looks like, sure enough, if I count it down, I'm at negative 7. And then the last thing to do, write the equation. So I have y equals my scale change, x minus 3, because we went in the positive direction, squared, and we went down 2.5. There we are in vertex form. All right. Basically out of time. All I'll say on this one is just because something's missing, we still know that A equals 1, B equals negative 8. We haven't really used the C, except it's the y-intercept. But in this case, we would think of it as 0. So I'm going to let you do that one on your own. Let me know if you have any questions. We'll see you in class.